Hello everyone. Today's topic of discussion is determinant. We have gone through the matrix already in two videos. Hope you have gone through the videos. So in determinant, we will make two to three videos. In the first part, which will be discussed today, in the first part we'll discuss about the definition of determinant and how we can evaluate a second order and a third order determinant by normal procedure and by using Sorest rule. And we'll discuss the concept of cofactor and minor in detail, how we can determine a cofactor, how we can determine a minor from a determinant from by seeing a determinant. So this will be the topic of the first part, and in the second part we'll discuss about the basic operation like addition, subtraction, multiplication of determinants. We'll talk about the properties, which is very important. There are 5 properties of determinant, which will be the key part in problem solving of the determinant. In the third part, we'll discuss about some problems. We'll try to cover up almost all type of problems in the third part. So let's start with the part determinant part 1. Determinant part 1. First of all, we need to know what do we mean by determinant. Determinants are the functions or the expressions of a number which is associated with a square matrix. I'll repeat it once again. The determinant is an expression or a function of a number which is associated with a square matrix. It is very clear from the definition that it is always associated with a square matrix. That means there is no chance of getting any rectangular shape or rectangular matrix. We'll always deal with the square matrix things. So in case of order of a determinant, it will always be same number of rows with same number of columns. That means 2 into 2, 3 into 3, 4 into 4. It will be like this only. So in case of matrix, there are several similarities and several dissimilarities with the matrix of determinant. So in case of determinant, we are going to study how we can evaluate. Each and every determinant contains a value, whereas matrix does not contain a value. We cannot find the value of a matrix, but we can find the value of a determinant. Now we have several other properties of determinant too, which are very interesting, which are very new actually. And first of all, we'll start how we can evaluate a determinant. First of all, we'll start the evaluating a second order, then we'll go to the third order by normal procedure, then we'll move to the Sorest rule. So let's start with evaluating a determinant. Several questions will come around and we'll discuss about whenever the situation comes. So let us take one example like A. Minus 1, 1, 1, 2, minus 2, 2, 3, 3 and minus 3. Let this be a determinant. Now, first of all, we'll discuss that how to show or how to indicate that this actually looks like a matrix, but we are saying it as a determinant. So how we can discriminate, কিভাবে আলাদা করব যে এটা determinant এটা matrix. আমরা ম্যাট্রিক্সের ক্ষেত্রে দেখেছি, we have seen when we have used the signs for matrix, we have always used the third brackets like this, but here we are using only the straight lines. That is the main indication of a determinant. That is the main indication, and we have seen that we always used to write A as a matrix, but in case of determinant we cannot write it like this. We have to write like this, mod of A. That means mod of A, that means determinant of A. It can be written like this, and it can be written like this also, determinant, det of A. That also means the same. Determinant of A, it can be written like this or this. Now this is clear by now, I guess. Then we'll move to how we can solve, how we can evaluate a determinant. একটা determinant কি করে value বের করা যায়. So this is a determinant of 3 into 3 order. We'll take another one example of 2 into 2 order. So we'll write one example, that is 4, 3, 7, 8. Let this be an example. This is a 2 into 2 order determinant. It is very easy to understand 2 into 2 because there are 2 rows and 2 columns. Now, we need to understand that how we can find the value of a determinant by calculation. So, first of all, in case of 2 into 2 order, in case of 2 rows and 2 columns, we need to just calculate like this and this. Follow the arrows. First we will do this and second we will do this. First we will do like this, 4 into 8. It will be 4 into 8 minus, it will be 7 into 3. Always the minus sign will be there. Always the minus sign will be there in case of solving. 8 into 4, I will repeat it once again. We will start from the down and we will go to the left, that is 8 into 4 minus 7 into 3. Again from down to upwards. Follow the arrows. So it will be 32 minus 21, that is 11. So this is the value of the determinant. So we can say that the value of the determinant B is equal to 11. This is how we can find the value of a 2 into 2 order determinant. Hope it is clear now. So note it down if needed. Then we will move to the next one, that is 3 into 3 order, which is written here. So in case of solving this, we need to understand so many things. First of all, we can solve a determinant by any row and any column. By any row and any column. I mean it. Any row, any column. Any column. We can use like this, we can use this, we can use this, we can use this, anyone. Then how to do? What is the funda? What is the basic concept behind this? First, we'll learn for the easiest one, that is the first row. We'll evaluate the determinant by the first row itself. Now we'll write minus 1 into, we'll just place this like this. We'll just hold it like this. Whatever thing remains here, that is minus 2, 2 and 3 minus 3, we'll write it like this. Minus 2, 2, 3, minus 3. Next, we'll do the same, that is minus 1. We'll do like this. So whatever things are remaining here, 2, 2 and 3 minus 3. 2, 2 and 3 minus 3. And for the next one, we'll do it like this. So what are the things remains? 2 minus 2, 3, 3. So it will be 2 minus 2, 3, 3. Now, there are several questions will come to your mind. First of all, we have written minus 1 here. We have written minus 1 here. We have written plus 1 here. This minus 1 is justified because we had minus 1 here. But this minus 1 is not justified because there is no minus in front of this. And whereas we don't have any minus, but we are using plus here. Here we are using minus. There the confusion starts. But there's nothing to get confused. We'll just move to another concept. We'll solve it later. These things, it is getting used as it is. That means we are using plus here. We are using minus and we are using plus here. So these things, this plus, this minus and this minus, these things are called as cofactors. These are called as cofactors. And these short type of determinants, 2 into 2 order of determinants, are called as minors. These are called as minors, that is minors. These determinants are called as minors, and the signs that is coming out here, plus, minus, plus, that is the cofactors. Now, we need to understand that from where the cofactor comes. What is the logic behind this plus, minus and plus? First of all, we'll write it like this. We have seen that we just turn the elements like this. This is the first row, first column element. This is the first row, second column. This is the first row, third column. This is second row first, second row second, second row third, and third row first, third row second, and third row third. Now, the concept of cofactors is like this. We have to determine the sign by calculating like this: -1 whole to the power, be very careful, -1 whole to the power row number plus column number. That means এখানে কি sign হবে, whether it will be a plus, whether it will be a minus, that will be determined by this formula. এই ফর্মুলাটা ইউজ করব কি করে? হাউ টু ইউজ দিস ফর্মুলা? এইখানে এটা ফার্স্ট রো ফার্স্ট কলাম, মানে এই ধরনের এখানে যে এলিমেন্ট আছে তার আগে যে প্লাস বসবে সেটা আমরা কি করে পাবো? সেটা আমরা ডিটারমাইন করতে পারি -1 হোল টু দি পাওয়ার, এখানে রো নাম্বার কত, কলাম নাম্বার কত, 1 1, সো উইল রাইট ইট 1 + 1, সো -1 হোল স্কোয়ার। আমরা জানি যে মাইনাসের উপরে যদি ইভেন বা জোড় সংখ্যার পাওয়ার থাকে, সো ইট উইল অলওয়েজ বিকাম পজিটিভ, সো ইট উইল বি 1, তার মানে এটা প্লাস সাইন আসছে, দ্যাট ইজ ওয়াই উই আর ইউজিং প্লাস। নাও if we calculate for the second one, for this one, so it will be 1 + 2, so it will be -1 whole to the power 3. আমরা জানি যে অড নাম্বারস থাকলে মাইনাসের উপরে সেটা সবসময় নেগেটিভই আসে, সো তার জন্য এখানে মাইনাস এসছে, বিকজ দিস ইজ দ্য ফার্স্ট রো সেকেন্ড কলাম এলিমেন্ট, this is the first row second column element, and this is the first row third column element. So for this what will come? -1 whole to the power 1 + 3, that is -1 whole to the power 4. So this is also an even number, so here it will come plus, that is why we are using plus. If you do the calculation and you will find like this, this is the chart you will get. This value will always be plus, this is negative, this is plus. The cofactor not always be plus. The cofactor here is always plus, cofactor here is always minus, cofactor here is always plus. Like this it will go on. So I think the concept of cofactor is clear by now. I'll repeat it in a small time, that cofactors are determined by seeing the number, the order of the element where it is situated. Now if the element is situated here, that is 3 + 1, that is third row first column element, so the cofactor will be -1 whole to the power 3 + 1, that will be -1 whole to the power 4, so it will be +1. So we can see, we can compare, here it is written as plus. So this is how we can generate the cofactors. That is the basic logic how we can calculate the cofactor. So we'll move forward. Now we have gone through the these are the cofactors and these are the minus. Now -1 was there. Now we have already learned how to solve this kind of determinants. We have seen that we have to do the multiplication like this and minus this. So it will be -3 into -2, -3 into 2. Now it is -1, so it will be -3 into 2 and minus of 3 into 2. It is like this, and +1, 3 into 2, minus of 3 into -2. Now we will calculate minus it, whatever it is coming, +6, that is +6 -6, and now -1, that is -6 +1, that is 6 + 6, that is 0. This one is +12, this one is +12, that is 24. So the value of the determinant is 24 here. This is how we can calculate the value of a determinant. Hope it is clear by now. I'll repeat it in a quick recap, that if we have a 3 into 3 order determinant, then we can find the value, we can evaluate the determinant by any of the row or any of the column. Now we have used here the first row. So first row, in case of first row, we need to remember the cofactors, otherwise it will be the values will differ, but it should be same always. But because one determinant cannot hold different values, it will always have the same value. So in case of expanding by this the first row, we are using the cofactors and we are constructing the minus by following these steps, and we are calculating. Now we'll find the value of the same determinant by using let us assume that any of the column. Okay, we'll do this. We'll do by this column, we'll expand and we'll find the value. We'll see that whether the value matches or not. Now We are going to expand by using this column. So we'll write it like this. 1, what is the cofactor of 1? Here it is plus only. So it will write plus 1. And what will be the minor? We'll just do like this. What are the things remain? 2 minus 2, 3, 3. 2 minus 2, 3 and 3. Now for this, what is the cofactor? It is minus plus minus. So we need to be very careful in case of writing this. Now if we do like this, then what will remain? Minus 1, 1 and 3, 3. Minus 1, 1 and 3, 3. Now for this, minus 3 plus minus plus. So it will be minus 3 only. So it will be minus 1, 1, 2, minus 2. Now we will do the same calculation, that is 1, 6. We're just not writing every step. Minus minus plus 6. Now minus 2 into minus 3 minus 3. Now we'll do like this, my plus 2 minus 2. So it is 12 minus minus plus 12 minus 0. So it is 24. So previous value was also 24. We can expand by using any row or any column of a determinant for finding the value or to evaluate a determinant. Hope it is clear by now. Now we'll move to another procedure of solving or of getting or finding out the value of a determinant. So let us start with that procedure. Next procedure means we are going to use Saurus rule. S-A-U-R-R-E-S, Saurus rule. Saurus rule. What is Saurus rule says? First, you just write it like this: 1, 1, 1. Write your determinant first. 2, 3, 3, minus 3. Repeat these two columns again. Minus 1, 2, 3, 1, minus 2, 3. I hope you have understood. First you write your determinant, then write these two columns again. First two columns, this column and this column again. Now put the arrows here like this. Okay. What is the value? We need to multiply these three things. Minus 1 into minus 2 into minus 3. Now we'll do the plus 1 into plus this one, 2 into 3, plus 1 into 2 into 3. Now minus. We'll do the same for this. Like this. So we'll write 1 into 2 into minus 3 plus minus 1 into 2 into 3 plus 1 into minus 2 into 3. Now we'll do the calculations. So minus 1, that is 3 minus, that means minus 6. Here only plus 6 plus 6. Now this is coming at minus 6. Minus 6 minus 6. So we'll do the remaining part here. So it is minus 6 minus plus 6 minus 6, 0, 0 plus 6, that is 6. Now minus of minus 18, so it will be plus 18, so it is coming out as 24. So first, don't get confused. First I will repeat the steps once again. First you write your determinant, then repeat the first two columns again. Then do the arrows from top to down, up to down, then like this. Then write the total steps, minus, just draw the arrows from up to down like on the opposite direction, and write the steps like this and do the calculation. So you will also get the same result. We have calculated the value of the determinant by three procedures, by three methods. Now in each case we have seen that we have found the same value. That is the concept. Whatever procedure we use, that doesn't matter, but the value of the determinant will always remain same. Now we'll just remove it. Now we'll move that to the next part, that is, we have seen in case of matrix. Let us see that if a matrix was given like this: 1 2 3 4 5 6 2 3 minus 1. Now we have if we have multiplied 2 with this matrix, then we have seen that all the elements are getting multiplied, that is 2 4 6 8 5 12 4 6 minus 2. It was like this. But in case of determinant, it is not the same. In case of determinant, if we have that same determinant, same as determinant 4 5 6 and 2 3 minus 1, and if we want to multiply any number, that is 2 or 3 or 4, whatever, you just need to do the multiplication. You just need to do the multiplication with any of the rows or any of the column, not to every row or column, any of the row. That means we can write it like this also: 2 4 6, that's it, 4 5 6, all the remaining will be same. You can do like this. We will just multiply this one. You can do like this, no issues. 4 6 minus 2, we can do like this. So this is also a property. We will discuss the same, as the values does not differ in the next part within the property of the determinant. So this is all for today's video. Hope you have understood the concepts whatever we have discussed in the part 1. Go through the PDF which we have already sent. I have already sent it to you, and try to understand by seeing the video. Try to clear the concept. If any doubt arises, then text me. Thank you for being here. Thank you.